Hey there folks, welcome to today's video. While I'm in the middle of busy uploading all the different Battleship video series, parts of the video series, it's getting a bit tired and I'm getting a bit angsty to do a little bit more coding in between, editing the videos and things like that. So I thought I would do a Minesweeper game and see if I can get it done, just a text version of the game, but see if I can get it done within 1 hour. I have made the game before, it was a couple months ago. I'm going to try and give it a go, and let's see if I can get it done in under an hour. Right, let's get started. So we're going to have our import modules just like normal. If we keep making mistakes, import modules. Then we're going to have our variables. Under that we'll have our dictionaries and lists. Right, and then below all that, call functions. Below that, up here by our variables, we're going to have, don't forget our section for functions. Alright, and then at the very bottom will be our run game. Alright, so let's start off. The first thing I'm going to go with the game difficulty. So I'm going to create a variable. We're going to make this, it's Minesweeper. We're going to make it straightforward with these 10 rows and 10 columns. First, let's go with I'm going to create a dictionary called difficulty. And in that dictionary, I'm going to have easy mode. And under easy mode, I'm going to have another dictionary. It's going to have rows will be equal to 10. Calls will be equal to 10. Number of mines will be equal to 10 as well. Okay, that will be the easy mode. Medium mode, that will be rows equal to, let's make it 15. 15. Columns equal to 15, and mines equal to 20. Alright, I think to save time I'm going to copy paste this line down for hard. Easy, medium, hard, which will be hard. Rows, 15 rows will be, the harder rows will be 20, columns will be 20, and then mines will be 40. Let's go one more difficulty setting. Let's go for extreme. In our dictionary it's extreme. That'll be rows will then be 25, columns will be 25, and the number of mines will be 80. Alright, so that's my difficulty settings. So we've got our game difficulty. What's the first thing we do? We need to create our game grid. So under my variables, what are my variables there? Variables, GameLogic grid. We'll just call it GameLogic. That'll be equal to a list. List for now. I need to create a function. Define, create, GameLogic. And it needs to take a while. It's going to take rows. It's going to take columns. Alright. So what we're going to do is we're going to create a GameLogic. So we're going to start off with an empty list, logic list, will be equal to empty list, and then for row in range rows, then for, then we're going to have a row list, which will also be an empty list, dictionary or a list, and then for col in range columns, right, for column range columns, row list dot append, and it's just going to be a space, an empty space, just like that. And then once that for loop for columns is ended, we're going to go to our logic list, and we're going to append our row list. And once that row for loop is completed, we're going to return our logic list. Okay, so we create a functions, GameLogic, call the function create GameLogic, rows, columns. Oh, you see now. We're going to our first snag already. We've got difficulty, easy, medium, hard. So I could just pass it for now, 10 rows and 10 columns, and then we'll create the GameLogic grid, and that's fine. That wouldn't be an issue. But I think the first thing we need to do is let's create a variable difficulty equal to none for now. So let's just create a difficulty function. Choose difficulty. It's just a straightforward function. Select Minesweeper difficulty. Alright, so valid choice. Valid choice is equal to false. We want to fall or while. So while valid choice, while not valid choice, answer is equal to input. Please select a difficulty setting. Right, and before it shows that, we just want to print out difficulty, then go easy, medium, hard, and then extreme for extreme mode. Okay, class up easy. If answer dot upper, not in, so basically we've got M, H, X. So the answer dot upper is not in those things. I will continue. Else, if it is in those 4 letters, valid choice will then be equal to true, which will break out that while loop, and we return then break out a little bit. So if answer dot upper is equal to E, return easy. And if answer dot upper is equal to medium, return medium. And if answer dot upper is equal to hard, return hard. Else return extreme. Right, that's straightforward. That's our choose difficulty function. So here I'm going to call it our choose difficulty function. Our choose difficulty, choose diff variable. We're going to call our choose difficulty function. All right. Now in my CreateGameLogic, I actually need to know the number of rows and the number of columns, and that's depending on the difficulty setting. So we need difficulty as my variable. And then here in my for row in range rows, I'm going to change that to say difficulty. Difficulty and chosen difficulty chosen diff, and then the last one will be rows. So I'm calling in the difficulty, I'll be calling, so I'll choose the easy difficulty, I'll be choosing easy, and then in that dictionary I'll be using the easy, and then the rows, which will be 10. Same thing I need to do for columns, difficulty, chosen, diff, cols. Right, let's just go ahead and run this quickly. What we can do, down below run game quickly, we'll just simply for GameLogic print that line. Okay, if we run this, choose the difficulty setting, we'll go with easy. The object is not subscriptable. Which integer object is not subscriptable? Oh, of course, in my CreateGameDictionary here, I need to change this to choose diff and difficulty. I need these variables to be below the dictionary lists. Alright, where are we now? So if I run this now, easy, I have a grid of 10 by 10 spaces. Fantastic, that's what I'm looking for. Okay, the next thing I need to do, logic, I need to insert the mines into the GameLogic grid. Insert mines, chosen diff, difficulty, and then GameLogic. Okay, great. Not insert mines, I need to insert the mines. So to insert the mines, I can descriptor here, randomly selects and positions the mines onto the game grid. Okay, in my input modules, I need to import random here. So valid option is going to be select choice and stick choice. Valid choice is equal to false, while not valid choice. So while not valid choice, some x coordinate is going to be equal to random, rand int 0, and mistake. Random dot rand int 0. So I need to know the number of rows there are. How many rows are there? So that will be my difficulty setting. Chosen diff rows. Okay, so rows of 10, and make that -1. Because remember, it goes from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so that's my x coordinate, my x position on the grid. My y position will be the exact same. 0. I'm just going to copy and paste that line. It's quite a bit of typing to go in. Except instead of column rows, I'm going to go with cols. Alright. Now what it needs to do is it needs to do a check to make sure that that position is a valid position. So if GameLogic X position Y position is equal to a space valid choice will then equal true. And we can somewhat break up while we're at it. Might as well. Don't need to actually choice will equal to true. So if it's valid position, if it's not, it will just continue the while loop. So I'm coming out of the while loop, below the while loop or valid choice loop. We've now got our X and Y positions. We then want to go ahead and insert our line into that position. And then we're going to say GameLogic X, GameLogic Y, therefore equal to X. Okay, so here's our line. So this needs to be done. So that's for one mine. We need to do for the number of mines there is. So we're going to go create a for mine in range difficulty chosen def. Right. And then I'm just going to go ahead and indent this whole line here. So we have our X and Y positions, GameLogic X, Y, Okay, so that's going to input 10. So you have my CreateGameLogic. Before we return the logic list, I think I want to, in there, I want to call this InsertMines def difficulty. The logic list. Alright. So there we go. Now we're going ahead and create our mine. So if we run this now quickly, and then we say we want it easy still, we have our mines being reflected in our name grids. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 mines as is expected. Alright, the next thing we need to do, and this one's going to take a little bit longer, is we're going to go and find all the, we're going to add in the numbers for all the adjacent tiles to the mine. All the cells that are adjacent to a mine, you know, they receive that number of how many mines are next to them. So in order to do that, we're going to create a function called adjacent cells. Adjacent cells. We need the game logic. And I think that's pretty much it. Alright, so what we're going to do is we're going to loop through every single cell on the board. And if the cell is an empty space, then we're going to check all the cells around it to see how many mines are next to that space. And if there's any mines next to that space, that cell will no longer be an empty space. It'll be it'll have a number assigned to it. Excuse me. Alright, so the first move we have 4, we have X, and then row in enumerate game logic. Right, and then for Y, call cell in enumerate. Right. Alright, so now we're cycling through each row, and then we're cycling through each item in that row. Right. Now we're going to do a bunch of like checks, if lookups and things like that. So in order to do this, we have our X and Y positions. So the first thing we need to do is we're going to check the north squares. We're going to say if X does not equal 0, meaning that we're not in the first row. Right? As long as we're not in the first row, we will do the following checks. Alright, then we're going to say if game logic x minus 1, right, y is equal to space. No, it's not a space. It's equal to x, because we're checking for if it's next to any y's. If GameLogic x minus 1, y is equal to x. Okay, we actually need to include a variable here. Each cell is going to have a cell count. I'm just going to start off with a value of 0. So if x does not equal 0. And before we do that, for y cell, let's just check if cell does not is equal to space. That's the first one we need to check. Is that cell equal to a space? So cell cannot be equal to 0 if x does not equal 0, which means if we're not in the top row, if GameLogic x minus 1, y is equal to x, cell count plus equals 1. Right, so that's x directly above it. Now we need to look to northwest and northeast, which means y also needs to be a minus 1 and a plus 1. So before we do it, we need to make sure that y does not equal 0, which means that we're not in the very first column. And if y does not equal 0, right, if GameLogic x minus 1, y minus 1 is equal to x, cell count plus equal 1. Then we're going to check if y is equal to GameLogic, the length of that GameLogic, length of that GameLogic. So we know that the length of it is 10. There's 10 blocks in there. However, when it does a y circling, it's only going to be up to number 9. So we need to make sure. So we're going to say if y does not equal length of GameLogic, minus 1. If y does not, if GameLogic x minus 1, y plus 1 is equal to x, cell count plus equals 1. Alright, so we've just checked. So if you've got your square, you've got 9 blocks around it. 3, 4, 5, 6, 7, 8. 8 blocks surrounding it. The 9th block will be the middle block. So we've just done the check for the top 3 blocks. We need to do a check for the 2 middle blocks. So for the 2 middle blocks, we're going to say if, basically we're going to save time, we're just going to copy this to the y checks. We're just going to copy the 2 y checks. Check the indentation is correct. If y does not equal 0, but you're on the x square, it's going to be just x. Right? And over here, that's also just going to be x. So now we're checking the x to the cell to the left of our current cell and the cell to the right of our current cell. Then lastly, to save time, we're going to do the check on the southern blocks. Cells, the southern cells. So that's to do that check, we're going to then GameLogic minus 1. So if the x is not minus 1, it's not the last one, so we'll have x plus 1, and then x plus 1, and x plus 1. Right. Now, these adjacent cells, once we've done all of that, we've checked, looped through all of the cells, we've checked all the cells next to each other. We have our cell count is equal to 4 or 0, whatever the cell count is. We then need to go to our GameLogic and dot and at the x coordinate and the y that we're talking about, we're going to change it to cell count. Okay, and inside CreateGameLogic Function, under InsertMines, we're then going to call adjacent cells. I'm going to pass it the logic list. We're quickly going to run this again. What we should see is our lines on the screen, along with a bunch of oh, okay, so it's printed all funky and weird. The reason for that is because I'm adding to the rows the cell count as an integer. I want to add it as a string. If we add it as a string, easy. Alright, let's just double check out our workings. Okay, so there's a mine. The cell directly next to it is there's only one mine next to it. Same with this cell, there's only one mine next to it. There's an indicator that says there's 3 mines next to it. There's no mines, there's no mines. There's 1 mine, 2, 3. 1, 2, 3. Some coffee. Well, there we go, guys. We have a game logic crack. So basically, we have our lines set on the screen. We have a bunch of empty spaces. Actually, all those zeros. I don't like the zeros. Can't forget rid of the zeros. What we should do rather is over here in our adjacent cells, before we include the cell count, we should say if cell count is greater than 0, then insert the amount. So if we run it now, we should still have a bunch of empty spaces. There we go. No zeros. So we have the empty spaces, and we have the 1s and the x's for the lines. And it seems to be working correctly. Right, so we have our logic built up. The next thing we need to do, and this is just an aside, I'm going to build a dictionary of all the cells, as well as their grid reference, and whether they are visible or not. So we have GameLogic. I'm just going to call it GameDict. It's going to be a dictionary. Find a function, create GameDict. We're going to pass it to GameLogic. Don't think I need to pass it anything else. And this one's straightforward. So we're going to go for row in GameLogic. Yes, okay, so here we've got a comment. In my function now, I'm going to create a variable called alphabet, and the variable is just going to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, E, S, T, U, V, W, X, Y, Z. Alright. So my game dictionary is going to be as follows. For x and row, then enumerate GameLogic. Right. For y, cell, then enumerate row. Alright, so now we're going to cycle through each row and each cell in that row again, and we're going to add these items to our dictionary. So I'm just going to create GameDictionary. Let's call it cell dictionary. Cell dict equal to, and it's an empty dictionary at the moment. In the cell dict, I'm going to go with cell dict. And I'm going to open brackets, so parentheses. I'm going to use my x coordinate space, and a comma space, and my y coordinate So my grid coordinates are going to be my key in my dictionary, and that is going to be equal to another dictionary. But in this dictionary, right, the first key is going to be cell reference, or cell ref, let's say that, and it will be alphabet Y letter. This will be which column? My columns are going to be alphabetical. Y, alphabet Y, plus string X. So that should be there, right? So just to do this correctly, so we're 100% sure it'll. Let's just give it a go, see if it works. Cell ref. Then my cell value will be GameLogic X, Y. And then my cell visibility will be hidden. Alright, so I'm going to create a dictionary of dictionaries. I'm going to let it run quickly. So I'm going to create GameDictionary. I'm going to create GameDict, and I'm going to pass to it my GameLogic. And then below that, I'm just going to for key value in GameDict.items print key value. Alright, I'm just going to let this run this program quickly. Okay, I'm going to make it easy again. And there's the first problem. That's what I thought. List indices must be integers or slices, not a tuple. And where's the exactly 996? That is. Ah, there. That's where I went wrong. There. GameLogic must be like that. I don't know why I did it wrong. Anyway, let's run it again now. Easy. Key value in GameDict.items and tuple object has no attribute items. Okay, so in my CreateGameDict function, we actually need to return the cell, that dictionary that we created. So that otherwise we're not assigning anything to our GameDict. Let's try running it one more time. Make it easy. Great, there we go. We've still got our game grade at the bottom. What I'm more interested in is this that we've posted at the top there. See this long queue of items. So there's my grid coordinate 0, 0, grid coordinate 0, 1, grid coordinate 0, 2, 0, 3, 0, 4, 0, 5, 0, 1. My cell reference is A0, B0, 0, 0, 0, 0, 0. Alright, so I don't want the cell references to be A0, B0, C0, because we're going to be, when we're playing the game and selecting our cells, we'll be using those grid coordinates. We'll be saying B2 or whatever. And having it in the dictionary as A0 is not really going to help us very much. So let's go back to our CreateGameDictionary function. And in my cell reference here where it says alphabet Y, which is correct, but under the string of X, we'll say X plus 1. Okay, I'm just going to run it one more time, make sure it's running what I want it to run. The dictionary prints, no errors. Let's go right up to 0, 0. Square, very first cell, A1, A1. Cell reference is correct. Alright, so now we've built the dictionary of our GameLogic. I like the dictionary. To me, for this game, I'm kind of using the dictionary as you would like an object. The dictionary is there for me to. So my cell reference, grid coordinate reference 0, 0 has now got a bunch of 3 attributes to it. A1 is an attribute. Whether it's visible or not visible is an attribute now. And if it's an X or a mine, or if it's just an empty space, or if it's an integer, So that's helpful. Right, and just look at the time. Okay, we need to hurry up a little bit. So here are my call functions. Okay, so now what we need to do is we've got our game grid, we've got our dictionary. So what we need to do is we need to get the player to make a selection. So I'm going to create a variable right at the bottom here. That's going to be called selection, and it's going to make selection, and that's going to be a function we call GameLogic. Okay, we're going to create a function called MakeSelection. Define MakeSelection. Actually, we need to pass to it the GameDictionary. So I'm going to say valid choice. It's going to be equal to false, while not valid choice. Alright, so while not valid choice, we go with answer is going to be equal to input. Answer is to input. Please select a cell to uncover. Why not? So then the player's going to put in, and then let's just put here as an example, a 1. Okay. If answer, so we're going to cycle through four values in game dictionary. Dictionary.values. If answer is not in values, cell ref. If answer is not in there, print your screen. Please choose a valid option. So firstly, if the answer is not in the values, cell ref, please choose a valid option. Or if answer not in values, cell ref, or I'm going to say for keys values in game dictionary.items. Right. If answer is not in the values, or okay, please choose a valid option. Right, so that's fine, and then on that one we say continue. If answer if answer is in the values if values cell viz does not equal hidden. So for each loop of the keys and values we can look here. If the answer is not in the values, answer is not in values. So if value cell viz hidden, print please choose a cell not already visible. Alright, continue. choice, then we equal to true. And then we want to answer grid will be equal to game dictionary keys game. True. Print answer grid. Return answer grid. Okay, I don't think this is quite going to work. Don't know why, but I got made this correct. I think I'm going to drop one more selection next. We want to pass it game dict. Let's just see what's happening. Statements from 111. There we go. Let's just give it a go. It's easy. A1. Okay, well, the first thing. Oh, it's got local variable answer grid reference before assignment. No, here we say if it is in there. So if answer is in values, so if, right? And values cell viz is equal to hidden. And here we'll say valid choice is equal to true. Answer grid will be equal to keys. Those two I can remove. Put it there. We can break the for loop. And I don't need this. Right, that. Easy. Okay, if we make it A1. There we go, it's fantastic, it's working. So we're putting it there. Let's try it one more time. Make selection. Please do it easy. We want to pull A10. A10. Which is my print coordinate is 90. If we try A11, easy, we'll say A11, there shouldn't be, it's just going to ask me again, we'll say K9, it's going to ask me again if I want J10, because we're in my J10 position, which is the bottom of the thing. Fantastic. Okay, and that returns my answer grid. So that gives me my selection. So once we have our selection, we already know that it is a valid selection. That's a valid selection. The next thing we need to do is we need to input input selection onto GameLogic selection. Input selection onto GameLogic. Define the function input selection onto GameLogic selection. GameLogic. Selection. GameLogic. Right. My input selection screen. Okay. So firstly, we're going to go GameLogic. Firstly, let's just assign x and y is equal to selection. Okay. GameLogic x, y. If GameLogic x and y position is equal to space, right? GameLogic x, y is then equal to let's just make an underscore for now. Alif GameLogic x, y. Come on, logic x, y is equal to, wait, Alif GameLogic x, y. Let's go with, remember there's those digits, there's integers on there. It's not integers, they're text, it's strings. But let's go with if GameLogic x y dot is digit, which means that it's a number. If that's true, actually it shouldn't allow us to select that block that will be visible. Oh no, although there could be, it wouldn't be looked for. Game, yes, hang on, that's what we thought. Going on GameLogic x and y. Now game dictionary, game dict. X, Y, right. Cell is equal to visible. Yeah, that's correct. All right. My GameLogic, if it's a number, nothing but game dictionary, x, y position, cell viz will be equal to visible. Elif GameLogic x, y, cell viz GameLogic x, y is equal to x, game dict x, y, cell viz. Right, so what we've got, okay, so we're just doing a checks input selection GameLogic. It's going to make all those things visible. Input selection into GameLogic. Okay, so what we're basically doing is we're updating our game dictionary. Whether the cells are visible or not, we're changing them from hidden to visible. And if it's an empty space, there's a function that we need to include there that we're going to build in a minute. I just want to build another function here quickly, PrintGameScreen, so we can see we need our game logic. Actually, we just need our game logic, and we need our game dict. Okay. So print Minesweeper Minesweeper. Let's just print that with a space on each side. Dot center. And then we want it to be 100 pixels, and it'll be in between. Let's put underscores. All right. Minesweeper, and then we're going to go with print mines remaining. No, let's call it cells remaining. Okay. We're going to come back to what this print cells remaining is. Okay, firstly, print. For GameLogic, so the number of columns. So I'm just going to include our alphabet here. One time as a variable. Alphabet, one more time as a variable. It will be A, B, C, D, E. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I'm not wasting time with that, but that's what I'm doing at the moment. So top line will be equal to space 1, 2, 3, 4, and then that is a 5. Right. Dot I'll justify 100 and spaces basically. No, I'll justify 100. Okay. Then we're going to go for I in range GameLogic 0. Then GameLogic 0. Right. Top line plus equals alphabet I. So if that alphabet I space enter space. Okay. Print top line. I'm just going to print the game screen quickly. Print game screen. Logic. Game dictionary. Print game screen. Okay, let's just run through this quickly. Easy settings. Cells remaining. Okay, we have our game grid right there. Okay, that's perfect. That's what I wanted. So in my game screen function again, come back to it. Okay, I've got my top row. Alright. Row 9 is going to be equal to if for I row in GameLogic enumerate GameLogic. Sorry, come on. Enumerate GameLogic for J cell in enumerate GameLogic. No, row. Sorry, row. Okay, so for each row. string I, right? Plus 1, sure. 1, 2, 3. Okay. And justify. 2. Dot just 3 spaces plus. All right. For JSON, enumerate row. So row 9 plus equals if game dict now ij dict cell viz is equal to does not equal hidden. So basically it's equal to visible. Row 9 plus equals if 1, 2, 3. So 3 cells in between 3, 4. Total of 4 cells. So if it's visible, it will be GameLogic dot just 3 space plus else will just be row 9 plus equals if 1, 2, 3 just be a hash. Right, let's just try this again. I'm quickly going to, okay, here at the bottom here, print game screen, print game screen, game logic, game dictionary. Okay. Let's just see how that prints out quickly. Easy. Okay. Why did it stop there? Why didn't it carry on? Okay, why did it stop there? Why didn't it carry on? Why didn't it print all the top line? Sure. For our game logic. What's going on? No, hang on. It's not working correctly. Still not working correctly. What's going on? Wow. For our own enumerate game logic, yes. Row 9. Because we're not printing the row line. Print row 9. Print row 9. Alright, let's see. It's easy. That looks fantastic. I mean, if we go A1, that looks good. Although, I want to be just want it to be center. Let's try one more time. Easy. A1. Nah, that's fine. But that's working, because our game grid is printing to the screen, which is fantastic. That's what we want. Got game grid is printing to the screen. Now the last thing two more things we need to do, and I think we might be running out of time here. Define check all adjacent cells. Okay, look, we need to take our coordinates, cell coord, GameLogic GameDictionary. Alright. So x, y is equal to cell coordinate, right? And then we're basically going to do a bunch of checks like we did on the last time. So I'm going to copy it across adjacent cells. We're going to have to amend them. There's going to be changes that has to go to it. But yeah. So we're going to copy. We don't need the for loop. But we do need these items. Alright. So my xy is equal to cell coord. So if let's just that cell coordinates. Okay, so my new x position, my new y position will be equal to xy. Okay, that's just what we get here. If new x does not equal 0, which means it's not at the top row, which is great. We're then going to do a check. If GameLogic nx minus 1 y ny is equal to and GameDict or GameLogic nx minus 1 ny is equal to, we just need to say dot is digit and GameDict nx minus 1 nx minus 1 ny cell viz is equal to hidden. Right. So if GameLogic nx minus 1 ny is equal to space, or if the next one is a digital, and GameDict nx minus 1 is still equal to hidden, then we're going to say GameLogic nx minus 1 ny so if it's a space, and it's or a digit, so GameLogic nx minus 1. No, not the GameLogic, I'm going to do the GameLogic. So GameDict space nx minus 1 y cell those then be equal to visible. Alright, so that's visible. We'll make those things visible. First we'll do is we'll make it visible. Alright. Then we've got if GameLogic nx minus 1 ny is equal to empty space, we'll check all adjacent cells with the chords will be nx minus 1, ny, GameLogic, GameDict. Alright, so that's everything to north. The other one says if ny does not equal 0, minus 1, is that ny minus 1, ny minus 1, ny minus 1, minus 1, minus 1, minus 1. Okay, the exact same. We're just going to say now if ny does not equal GameLogic len GameLogic 0 minus 1. So if it's not greater than ny plus 1, 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 ny plus 1. Alright. So that's the check of the top 3. So this shows show. Let's just go here where it says the and let's just enter it. So it's all the same line, so it looks neat and tidy. Better. Alright, so now we've done the check for the top 3 lines. Alright, what we've got is the CheckAllAdjacentCells. I'm going to copy this section of code. Alright. Paste there. So there's the top 3 lines. Now we're going to do the bottom 3 lines. If nx does not equal to len GameLogic minus 1. Len GameLogic minus 1. Right, so x is going to be plus 1. Nx is going to be plus 1. Plus 1. Plus 1. Nx plus 1. Nx plus 1. Nx plus 1. Nx plus 1. So nx plus 1. Nx plus 1. Nx plus 1. Nx plus 1. Plus nx plus 1. 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 Alright. That's the bottom row. Then we're going to do the middle row. We only need the ny sections. Paste there. If 1 is equal to 0, so then nx is just going to be nx, no nx plus. Nx, 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 nx. Right. Give that a try. Let's play, run. Easy mode. We're going to select J10 and recursion error. That means we are going through. Okay, that's fine. We're checking to see if there's a space. Then, if there's a space, it pulls. So if there's a space in that block, all right. Okay. We then need to actually change that block. So GameLogic is going to be equal to underscore. Right? We need to do that everywhere actually. GameLogic, let's just copy paste. It's going to be equal to underscore. The same for this line. Otherwise, we're just constantly referring to cells with spaces in it, and all the cells have space in it. As long as there's a cell with a space in it, it's going to call another function on that, and we end up with a recursion error because it's just going to cycle back and forth the whole bloody time, which is less than ideal. Next to this one. Right. Last one, or third to last one, is equal to underscore. Second to last one is equal to underscore. And then final one, the last one, not one, but the last one, underscore. Okay, if we run this now, we should get better results. Easy. Let's go J10. If GameLogic index ny plus 1 is equal to GameLogic index plus 1, which line is that? Line 202. Line 202 if GameLogic index. That there's the problem. X. Right. Let's try this again. Easy mode. J10. Hallelujah. It's working. Okay, so as you can see, it's now showing all of those cells, but it's also returned to us all of the cells that have digits in them, which is quite helpful. So now we need to actually put this into a game loop. So what we're going to do here is we're going to say run game is equal to true while run game. These items, right? And then what we need to do is we actually need to do a check to make sure that the game, if there's a winner or not. Let's do it up here. Check for win, lose. GameLogic. And we can pass to it GameDict. Right, check for win, lose. Let's create this function. Check for win, lose. And we're taking GameLogic and GameDictionary. Alright. Run game. So we're going to change our run game. Can't be there, it needs to be over there. Okay. Run game. Check for minutes. Total mines will be equal to game difficulty. Choose diff. Total mines will actually difficulty. Choose diff. Mines. Right, so there's a total number of mines. Total cells is equal to difficulty. Choose diff rows multiplied by difficulty. Choose diff columns. cells. So available cells, let's call it available cells is equal to total cells minus total amounts. Right, available cells. Visible cells is equal to 0 for values in GameDict. Values in GameDict dot values if values cell vis does not equal hidden visible cells plus equals 1. Okay. Check if visible cells is ever equal to available cells. Print congratulations. Congratulations, you have won, and return false. If values cell value is equal to x and values cell this is equal to does not equal hidden. Print cabo return false. False. Alright, check for windows. Got that. Let's how's that number 2 and the 7 and 220. Let's play Minesweeper. Just use the difficulty easy. Okay. J10 because you can see it there. Cool. That's fantastic. Didn't open up all of that. Open up a lot of it. Let's just okay. We're going to open up A1. Or why did it stop? So we're going to the game repair. Run game. Are we not calling it? Yeah, put some game. One game is equal to CheckForWinLose. Then why did it end? We can have that. We don't need that. No, wait, we want that. We can have that one. So yeah, of course, else return true. easy mode. Let's go with J1. A10. Cool. A1. A1. Cool. Next large slide we have J1. Because we actually just play the game. D5. D5 is fine. E5 is fine. H4. H4. J4. Ooh, damn. We hit a mine and the game ended. Boom. Let's play it one more time. Let's play on extreme. Yes. Alright. Oh, we've got a nice cheat sheet right about it. Let's go to J10. That'll take up J10. No, not J10, it's Y25. Okay, that's a nice clean section. A1. A1. A4. A5. Okay. W20. W18. X18, X17, X16, right, Y16, Y17, Y20. Seems to be working just fine. L25, L25, M25, N25, and M24. Fantastic, all of this seems to be working. This is a fairly large game, I'm not going to need to finish it. Let me stop it there. Let's go with let's do 10. Just a quick test. If we win it, easy. J10, A10, right. Okay, D10. Oh, damn it. Easy. Let's go easy again. J10, J1. E3, E2, E3, okay. Once I go to this, 2, 3, 4, so D6, okay. A8, A7, B7, right, B6, A6, A4, A3, B3, okay, A2, C1, D1, Congratulations, you have won. I don't think we made the hour-long message. I think we went over, had a bit of debugging on the recursion method there. But I hope you enjoyed this video, and I'll see you guys in the next one. Bye for now.